In last class, we did solving linear equations, and today we're going to do graphing. Graphing linear equations. And functions. We learned how to solve a linear equation, and if you remember that we have several rules that we can add or subtract the same amount on both sides, and also we can multiply by the same number or divide it by the same number for both sides, and then we solve the equation. At the end we get x equals to a value, or we can solve for a letter if we have like several letters in this linear equation, and then we can solve that. That was the last thing we learned in last class. And today when we talk about this linear equation, we graph it. That means we have to show the picture. When we want to show the picture, the first concept we need to know is quadrant. Quadrants. Okay. We need to learn this is x, y, and here's a 0. This is called a coordinate plane, and in the future you're going to learn more complicated one, but so far we learned just this. It's a two-dimension, x and y, two axes. They're vertical. They're one horizontal, one vertical. And here's a 0, and that has a 1, 2, 3. It was like the number line, right? So, and also for y, we also have 1, 2, 3 like this. So -1, -2, -3, and so on. So you see this one axis, another axis, we call this x-axis and a y-axis. And this too, because the are perpendicular to each other, which means they intersect, form a 90 degree. That will split the whole surface or whole plane into 4 areas, and each one is called a one quadrant. And this is a quadrant 1, and this quadrant 2, and here is a quadrant 3, and this one is quadrant 4. Okay, this is the way to write 4. It's an I and a V, and that V means a 5, right? So I to the left of it means subtract. So this is a 4. This is equal to 4. Okay, so we learned the quadrant, and then we're going to do all the things in this class on this coordinate plane. Okay, so we have to be very familiar with all those 4 quadrants. So later on when I say the third quadrant, then you know it's somewhere here. All right, and for every single point on the surface, on this two-dimensional plane, and each point that has 2 numbers associated with it, which is the x and the y coordinates. So we are going to do, the next thing is how to graph a point, or how to plot points, and what is the relationship between the point and the xy coordinates. So we're going to plot points. Okay, so we are going to have this and make it pretty big. Try to make it better. So this is x, and this is y. And a lot of books, they also put the little arrow here. They put the arrow here. That means it's going down forever and it's moving to the left forever. Okay, so here's a 0. Here's 1, 2, 3, 4, and a 5, and 1, 2, 3, 4, 5, 6, and to the left of the x-axis we have -1, -2, -3, and -6, and from 0 and below that was on the y-axis. We also have 1, 2, 3, that's -3, and this is -6. I just didn't have enough space to write every single number, but you got the idea. So this is the xy coordinate plane, and I would ask you to plot this. The first number, I give you a paired of number that is 2, 1. What does this mean? That means the x, there's a number, a point. I give this point a name. I call that capital A. X coordinate is 2 and a y coordinate is 1. When the x coordinate is 2, that means you start from this origin, move to the right by 2 units. See 2, you go to the right by 2, and then this y coordinate, that is 1, so that's on this y-axis, right? That's what we're talking about, up and down. So when here's 1, then you're going to move up by 1 unit. So you move to the right by 2, up by 1. So move to the right by 2, up by 1. Here it is. I found that this is the point 2, 1, or I call this A. So this is how do you plot the point. So let me ask you to do another one. Okay, -3, 6. Right, because this x coordinate is -3, so you're going to move to the left by 3 units, and then you're going to go up by 6 units. So let's move 1, 2, 3 to the left by 3, and then we're going to move up by 6. So that goes right here, and that is the B, and which is -3, 6. All right, and let me ask you to do one more. -3, -3. That means you're going to, starting from this origin 0, 0, you go to the left by 3 units, 3 units, down by 3 units. Remember here, positive means to the right, negative means to the left. Positive on the y-axis, on the y coordinate, that means going up, and the negative means going down. So we go left and down. So left by 3 and down by 3. So that is this point. -3, -3. All right, now one more point. I ask you to do 2 and -6. Where is that? We're going to move to the right by 2 and go down by 6 units. So move to the right by 2 and then go down by 6 units. We got right here. This is the point D, and the D's coordinates are 2 and -6. Phew, see, we have A, B, C, D. This is how you plot the point. If a point, x and y coordinates are given, then you can just come here to this coordinate plane, and then you can find where that point is, which means for every pair of numbers, there is a point in this plane associated with that or corresponding to it. All right, now if I give you a point, can you find the xy coordinates? Let's see, what about this one? There's a point here. Can you find the xy coordinates? How do you go from origin to here? You move to the left by 6, you go up by 1. So for this point, the x coordinate is -6 and the y coordinate is +1. See, I give you a pair of number, you can find the point. If I put a point here, you can find that a paired number, which means you can find the xy coordinates. You're going to see a lot of exercise usually at the back of the book to ask you to do this, but you can do a lot of practice. Well, I ask you to notice something. For every point, for all the points in the quadrant 1, all the points here, because you're going from 0, you move to the right and up. So the coordinates has a positive, right, up. What about here? What about this quadrant 2? You move to the left, so the x coordinate must be negative, but the y coordinate is positive because you're going up. Therefore, if you see a number with, if you see the coordinates with a negative comma positive, that's definitely that point is on the quadrant 2. So very similar. Every point in the third quadrant, they must have a negative and negative. Two negative numbers, right? Negative x coordinate and a negative y coordinate. Now what about this? X is positive, y is negative. Okay, now I see this relationship is very, very obvious, isn't it? So that's how do you plot points in the xy coordinate plane. So you can go back and forth from the point to get the xy coordinates, or from coordinates to plot the point. Okay. All right. Now, after we plot the point, next one, I will ask you to graph linear equations. Okay, I want to be familiar with this. This is called a standard form of linear equation. Looks like this: ax plus by equals c. Okay, all the equations look like this. That is the standard form of linear equation. That should be just like a linear equation. All right, so let me give you an example, like x minus 2y equals 5. Here, that a is 1, right? A is the coefficient of x. So in this case, a is 1, and the b is negative 2, and the c is 5. What about x equals 5? Then the a, the capital A, the coordinate, the coefficient of x is 1. And what about b term? The b, the y term, there's no y, so b is 0. So in this case, a is 1, b is 0, and c is 5. Okay, so also I can have y equals negative 1, and which means a is 0, and the capital B is 1, which is the coefficient of this y term, and the c is the number on the right side. Okay, so I just add this up. A is 1, B is negative 2, and C is 5. Okay, so I really hope that you can remember this. This is the standard form. For all the equations look like this, that's a linear equation. And for any linear equation, you can write that in this standard form. Okay. Now, after we know the standard form, we can graph it. Let me just give you one example. I can ask you to graph y equals 3x minus 2. Wait a second. Y equals 3x minus 2. That's not a standard form. No, it is, because this is x term, this is y term, this is the number, and if you just need to move x to the other side or subtract a 3x, so you get a minus a 3x, right? Minus a 3x, minus a 3x on both sides. So we get a minus a 3x plus y equals negative 2. This is A, this is B, this is a C. That's a standard form. So we know this is a straight line. Now, if I ask you to graph this, it looks like a linear equation. And one important thing about equation is domain. If we review a little bit, do you remember what is a domain? Domain is what x value can be. It's a set of all the values that you can choose x. Okay, I will give you three important example. So let's say the first example. I ask you to graph y equals 3x minus 2. Domain is -2, -1, 0, 1, 2. That means x can only be these 5 numbers. Okay, x can only choose these 5 numbers. Let's do that. Which means x is 0, -1, -2, 1, 2. This x value, then you can just plug that in to get the y. So when x equals -2, y equals 3x minus 2, we plug in x equals -2. So that would be 3 times -2 minus 2. And 3 times -2 is -6 minus 2, that will be -8. So we have a point, -2, -8. When x equals -2, y equals, I didn't do this with the same length, I just did this, 8. And then the other side is -2, -4, -6, and -8. Did you notice that my unit, 1 unit on the x-axis is a little different than the unit in the y-axis? Okay, so when x equals -2, y equals -8, I have this. I have a solid dot. What about when x equals -1? Y equals, when x equals -1, 3 times -1, that is -3, minus 2, I get a -5. So 2, 4, 6, so I get this point. Okay, and when x equals 0, oh, sorry, that's -5. So I have -1 and a -5. And when x equals 0, I have a 0, and when plugging x equals 0 here, I get a 3 times 0, -2. So I have this point, right? X equals 0, y equals -2. And this one will be 1, comma, and I'm putting 1 here, 3 times 1 minus 2, which is 1. That's this point. And then the last one, when x equals 2, 3 times 2 is a 6 minus 2, which is a 4. So that's here. All right, so if I ask you to graph this linear function, but the domain is only a couple of points, a couple of numbers, only 5 numbers. When you graph that, you're going to find what? 5 points. Okay, so that's the first situation. Now the next situation, again, I ask you to graph this. I still ask you to graph y equals 3x minus 2. Later I'm going to tell you what this form look like. What is that called? It's not a standard form, but it doesn't really matter. So this is a line, and here the domain is all real numbers. That means x can be any real number. All right. Well, if that's the case, and I ask you to draw the line, I put x, see, I keep doing this, right? 1, 2, 3, 1, 2, 3, 4, 5, 6, and so I just don't need to write that many. If I want to draw this, I know this is a linear equation, and it's going to be a straight line. If you have 2 points, then you can draw the straight line. So let me just make x equals 1, and then that y will be 3 times 1, which is a 3 minus 2, y will be 1. So I have a 1 point, okay? And for x equals 2, y equals what? X equals 2, 3 times 2, that is 6, minus 2, you get a 4. So I have 2 points, 1, 1, 2, 4. Okay, so 1, 1 is here, and this is 4. 2, 4 is here. Okay, now, did you learn that if you want to draw a straight line, you only need 2 points? You don't need no more, right? So we can get this straight line. Extend forever. this is y 3x minus 2. What does that mean? This equation, and this line, they are the same thing. Okay, this is the graph of this linear equation. So they talk about the same thing. And also, I only give you 2 points. I just made these 2 points. I plug in x equals 1 and x equals 2. I get the y, I get 2 points. So if you connect these 2 points, connect them and extend forever, then to both sides, then you get the graph of this equation. It sounds interesting, isn't it? Yeah. All right. Now, one more thing. What about the next one? I just write here. What about the domain? I change that. Okay. X greater than or equal to 0. What does that mean? That means x cannot be negative, either 0 or positive. So when you graph that, you only take all the points with x greater than or equal to 0. Therefore, you don't have this part. So the graph looks like this. Let me show you the graph. The graph will look like. Okay, so that'll be this case. X is greater than or equal to 0, and you put a solid point here because it could be 0. Okay, if I put x is just greater than 0, then it's going to be like this. But here you put a circle because it cannot be 0. Okay, so we're gonna do this a lot later, but so far, see, we learned how to graph that, right? You put 2 points and then you connect them, you get this line. Now let me ask you to do the next. I want you to check if 1, 3, 4, negative 3 are on the line. Okay, so what should I do is 1, 3, 1, 3. Obviously it's not, so this is not. What about 4, negative 3, 4, negative 3? This is not. We can tell. All right, so that means these 2 points, they're not on the line. Or the other way to do that is you plug in x equals 1 here. You plug in x equals 1. Remember the equation is a 3x minus 2. So when x equals 1, y equals 1, right? And when x equals 4, that y equals what? 3 times 4, 12, y equals 10. So 4, 10 is on the point, is on the line. 1, 1 is on the line. That means for every single point who is on the line, their x, y coordinates must satisfy this linear equation. Make sense? That's the same thing. For every pair of x, y that satisfy this linear equation, then that x, y coordinates point should be on this line. All right? So that is the very interesting thing about the graphing. We connected 2 points, and then we connect them, and then we can graph. All right, now next one, I'm going to ask you to graph 2 special lines. One is a horizontal line, and another one I call this a vertical line. Do you remember I have a very special situation earlier that ax plus by equals c, and when a is 0, I only have a by equals c. Remember that? Or let me just make, there's no x. Let me give you one example. That will be y equals 3. Okay? So this is also a linear equation. And the other side, the other way, if I make b equals 0, then I have ax equals c. Give you one example. X equals 2. Okay, how do I graph this? x equals 2. Let me tell you, this is x, this is y, and 0, 1, 2, 3, 1, 2, 3. Okay. The first one, y equals 3. For this y equals 3, I can put 2 points. X can be anything. That's a good thing, right? So x can be 1, y is 3, and x is 2, y is 3, which is when x is 1, y is 3, when x is 2, y is 3. If they didn't mention x, that means x can be anything. So what you get is going to be this one. This is a horizontal line. And this one, x equals the second line, okay, x equals 2. In another word, there's some sentence they didn't mention. That means y can be anything. So x equals 2, y is 1, and x equals 2, y is 2. Where is that? X equals 2, y is 1, and x equals 2, y equals 2 here. Connect these 2 points, you get this vertical line. So this is x equals 2, this is y equals 3. Okay, now you see this? When I give you the equation that y equals a number, y, this is the y-axis, y is a number, so that means from that from that value, you just draw a horizontal line. Horizontal is this, okay, left to right. So horizontal line. So y equals 3, which is a horizontal line that passes this point 0, 3. And x equals 2, that means x is a constant, it's a number, it doesn't matter what y is. So all the point with the same x coordinates, that will form this vertical line. So x equals 2, that's a vertical line that passes through 2, 0. So you see where they are. Alright, these two are very special linear equation, but now we know how to do it. If we know y equals a number, we know it's a horizontal. If x is a number, then that's a vertical. So that's very easy. Alright, so we did that. And then next we're going to do is we're going to graph using intercepts. Okay, here's the concept. What is the intercept? X-intercept. X-intercept is the x value when y equals 0. Of course, the y-intercept will be the y value when x equals 0. Alright, let's work on this example. 3x plus 2y equals 6. Okay, can we find x, y intercept first? The x-intercept, that's what x is when y equals 0. So when y equals 0, we plug in y equals 0, then this 2y term will be 0. We have 3x equals 6, so the x is 2. Okay, and if I put x equals 0, then this part is gone. I have a 2y equals 6, then I get a y equals 3. When I graph, okay, y equals 0, which is the x-axis, x equals 2. And x equals 0 here, right? X equals 0, which is the y-axis, and the y is 3. What do you get? You get 2 points. The point is 2, 0. You get a 0, 3. So if you know the x, y intercepts, you just connect them and draw the line. That's your graphing. Alright, so this is very interesting because we don't need to plug in x and y remember we did earlier, we plug in x equals 1 to find y. We plug in x equals 2, we find y. And now we just plug in x and y, each of them to be 0, and then we get the other value, and that is the intercept. Intercept is that's going to go across the x or y axis. Where it go across the x-axis, this one is called x-intercept, and this one is called a y-intercept. So that's not a very hard it's not a very hard concept, but this is something that you really need to remember. Okay, x-intercept is the x value when y equals 0, and a y-intercept is the y value when x equals 0. And here I showed you how to do that. This is how do you graph using intercepts. Now, if I give you any equation, can you find the intercept? If you remember this, then you can find it. After you find it, just find these 2 points on the xy coordinate plane and then connect them. You can get the solution. You can get the graph. So that is the how to graph using intercepts. All right. Let me introduce a couple of important concepts for graphing. That's called a slope and rate of change. When we talk about a slope, you might think about it when you go hiking. When you go hiking, it's a little mountain, and this is you, right? So you go up, that's a slope, all right? Or if you go, it's a flat, then you probably go, it's a little easier, right? And when it's like that, so you're going to go, I don't know, it's hard. You're going down, and you're going up. Okay, going up. Okay, so what time do you like the slope? I like this slope, right? And I like this one. It's better than that one. But when you go go ski, you will like this one. You like a good slope, so you can ski. And there are a lot of situations like this. So this is what we'll call the slope. Okay. When I draw this graph, I always draw from left to right, and that shows going up, that shows going up, and this shows going down. Okay, so you're not going from right to left. So that's the first thing. Okay, we always move from left to right, and then we talk about the slope. Okay, now there is a definition about the slope, which is we're using a number to show how the slope look like, how is the slope, how steep it is. Okay, this slope look like it's greater than this one, right? And this one is quite opposite than that one. So how do you use the number to show that? Here's the formula. Slope is rise over run. Okay, the run is from left to right. And then the rise sometimes could be positive. Okay, let's see. If you go from this, okay, this is a run. We call this as run. Okay, I call this as rise. Now in this case, run is always from left to right. So from here to here is positive, and then rise is positive because it's going up. Therefore, this is a positive slope. And this one is the rise is here, and here's the run. Okay, so run from left to right, and then rise is from here to here. So this is also positive, but definitely this rise is greater than this rise. So I know this slope is greater than this slope. Now what about this one? He also, the run. Remember, run is always from left to right, okay? And then when you are from here, the y is this. And if you keep going, see it's going down here, down to here. So this rise is not really rise, it's moving down. Okay, it's drop. But anyway, we call this negative rise. So this slope must be negative. Okay, this is positive and this is negative. So we can see this. If you have a line look like this, that has positive slope. If you have a line look like this, that has negative slope. And if you have a line look like this, a flat, that means no slope. No, it means a zero slope. You look at this guy. So he's going from here to here. If that goes down to here, if it's a flat, okay, so he just keep walking, right? And the rise from here to here, but no run. Run is from here to here, but no rise. So rise is 0. The numerator is 0. So that's the slope is 0. What about this one? What about this is x, this is y. What is the slope of this line? Vertical line. No rise. No run. No run. So from here to here, no run. On the x-axis change at all, so no run, just rise. So you are divided by a 0. So this slope is called undefined because we cannot find it. We cannot calculate that. Undefined slope. So that's all the different situations of the slope and the rate of change rate, right? Because once we know the rate of change, it's a slope, same thing. All right, now once we know this, I will ask you theoretically, that's x, this is y. So if here's a point, I call this x1, y1. Okay, I think there's another point. I call this x2, y2. So I call this a point 1, point 2, and x1, y1, that's are the x and y coordinates of the first point. And this is the coordinates of the second point. All right, so for this line, what is the slope that passes through these 2 points? Now I ask you to find a rise and run. This is, I drop it to the x and y coordinate system so I can find them, okay? So this is x1, isn't it? And here's a y1. Let me just connect with the dot. Okay, connect to that. Connected. So here's x2 and this is y2. Now from here to here, the slope is rise over run, right? And what is rise and what is run? Slope is rise over run. Rise is from here to here, which is from y1 to y2. The difference is y2 minus y1. Okay, and run is from x1 to x2, so that is x2 minus x1. This is the slope formula. If I give you the coordinates of 2 points, if I ask you to find the slope of the line that passes through these 2 points, here's the formula. The slope is the change in y over the change in x. Okay, so if the change in x here is 1, so x1 just increased by 1, go to x2, so the denominator is 1. That's a unit change, right? So the unit change, unit or the rate of change is the same as the slope. All right. Now, once we know this formula, we can do a lot of things. I can give you any 2 points, and then you can find the slope. Let me give you here from -2, 3, and 4, 5. What is the slope of a line that passes through this point? The slope, remember the change in y, which is 5 minus 3 divided by 4 minus -2, which is 2 over 6. Simplify, you get 1/3. That's it. Okay, so this is the slope of the line that passes through these 2 points. So let me give you a couple of more examples. I have a negative 3, 2, and a negative 3, 6. All right, the slope will be the change in y, which is a 6 minus 2. Change in x is minus 3 minus negative 3. Wait a second. The denominator is 0. The top is 4. So it's undefined. I don't have enough space. So what is undefined slope? It's a vertical line, isn't it? Yes. Actually, the equation is x equals 3. Next one, 5, negative 2, this point, and 4, negative 2. What is the slope of the line that passes through these 2 points? Changes in y, negative 2 minus negative 2. Changes in x, 4 minus 5. The numerator is 0, denominator is negative 1. We got a 0 slope, which is a flat or horizontal line. That is y equals negative 2. All right. Just one more. 4, 1, 3, 4. The slope is change in y, which is 4 minus 1, divided by the change in x, which is 3 minus 4. So it's a 3 over negative 1. The answer is negative 3. Okay, so that's how you work on those questions. Given any 2 points, find the slope of the line that passes through these 2 points. Right, you should be able to do this. Well, after we learn the slope, we're going to do something important again. We're going to do slope and y-intercept form. Okay, looks like this. Y equals mx plus b. Okay, we have a single y, just one y on one side, and the x term and the other constant term on the right side. This is the slope in the y-intercept form. Of course, if you move this mx to the other side, that negative mx plus y equals b. What is this? That's a standard form, right? I'm not going to work on switching between the standard form and the slope-intercept form, but I'm pretty sure that you know how to do it because we already learned in last class. All right, now what does this mean? How to graph? Let me tell you a little trick. All right, now if I ask you to graph this, 3 equals 3x minus 2. Here's the slope. Slope is 3, and y-intercept is negative 2. Right. Y-intercept is negative 2. That's negative 1. Here's a 1. Here's a 2. And a 1, 2, 3, and so on. Okay. So we have 1 point. That's the y-intercept. We already know that. What about a slope 3? Do you remember slope is rise over run? And when run is 1, then the change in y, or that rise, will be just the slope. So when x goes up by 1, y will go up by 3. So that goes here. You have another point. Okay, so this is when x equals 0, y equals negative 2. When x equals 1, y equals 1. How do I get that? I can either plug in x equals 1 here, or I can just use the definition of a slope. Rise over run, right? 3 over 1. Therefore, I can just graph it. So that's it. It's very easy, isn't it? All right. So if you're given slope, if you're given y-intercept, this means you already know 1 point. And and slope, the next point when x equals 1, then y should change by 3. So you already know that. So this is once you're given the slope and the y-intercept form, and you should know how to graph this line. Okay. And the next concept is a parallel. Parallel lines. Now, you think about go up the hill, and then you go another hill, another person or another day you go by. You want to tell me that, well, they have the same slope. Okay, so that means they have the same rise over run. Make sense? So same slope, get parallel lines. Is that right? So if you have two parallel lines, they have exactly the same slope. Okay. So let me ask you, for the line 1 that passes through 1, 1, 2, 6, and the line 2 that passes through 3, 2, and 5, 12. So I ask you, are they parallel to each other? If you want to find if two lines are parallel to each other, you want to find whether they have the same slope. So this is slope 1. I call this M1. Will be the changing y, which is a 6 minus 1, over the changing x, which is 2 minus 1. That's a 5. That's a 5. For this one, I call this M2, the second slope. Changing y, 12 minus 2, over 5 minus 3, which is 10 over 2, and that is 5. The answer is yes. Okay, these two lines are parallel to each other. So that's how do you verify if two lines are parallel to each other. So if you write that into y equals m1x plus b1, and the other one is m2x plus b2, if these two are the same, then we know they are parallel to each other. At the same time, if you move that to the other side, you think about if you rewrite that into the standard form, then I tell you what, that should have ax plus by plus equals c1, and the other one should have ax plus by equals c2. They only have different constant term, and these two lines are parallel to each other. So that's a little bit more about the parallel lines. We know the next one is also a very special. From here, the very special case, a very special linear equation is called direct variation, which means we have this form, y equals ax. I just use the little letter a, but actually that is the slope, right? A is the slope. What happened to b? B is 0, and you remember that b is the y-intercept. What happened when b-intercept is 0? You get an equation, sorry, this is a line, it's not very straight, that passes through origin. Origin 0, 0. Okay, compare with other lines. Okay, this one is very special because this passes through the origin. So we call this y has direct variation with x. Okay, actually they just use a. Of course, it's the same as a slope. So that's just a very special case. And when a is a positive, you're gonna have like that, right? When a is negative, Okay. So this is it's a very special case. So let me ask you, 3x minus 1 equals 0. Is this a direct variation relationship? Well, I move y to the other side, I get y equals 3x. The answer is yes. Okay. What about x minus y equals 4? Then you move x or you move y. Anyway, you get a y equals x minus 4. Oops, you have this y-intercept, so this is not a direct variation. That's the only thing you need to know about the direct variation. The last part we're going to do graph linear functions. We did everything before is called graph linear equations. Now we're going to graph linear functions. It's very, very similar. The only difference is instead of writing y, we use f of x, which means y, that is a function of x. So f of x equals mx plus b, and that is the function. If I ask you to graph the function f of x equals 2x plus 1, can you do that? Yeah, you just treat this f of x equals y. So you have the slope is 2 and the y-intercept is 1. When you graph, you have, here's a 1 that passes through that. Okay. And when x is slope is 2, so when x go to the right by 1, y will go up by 2. So here's 2, here's a 3. Then you get another point. Then you just connect that. So that's how you graph it. Okay, so that's a very similar idea. And I would like to introduce a new term. It's called a parent function. It's very important. Parent function, that's f of x equals x. What is that? F of x equals x. Slope is 1, and it's a direct variation. So it is actually the 45-degree straight line. Okay, so 1, 1, 0, and this is f of x equals x. This is the parent function of all linear functions. All right. Now, how about if I ask you to graph f of x equals x plus 2? These two lines have exactly the same slope. Slope is 1. And then this has the y-intercept 0. This one has the y-intercept 2. So you are going to get this. What you're doing from the parent function to this, f of x equals x plus 2. You are, from the parent function, you shift up by 2, because all the y value will just go up by 2. See, you shift up by 2. So from the graph of parent function, shift up by 2 units. Okay, what about this? What about f of x equals x minus 3? So you're going to shift down by 3 units. Okay? Okay, that's the first thing. It's important. All right. Now we're going to do a little bit more. Let me just write that. f of x, the parent function, and which is the 45-degree line. Here x, here y. Okay, so this is f of x equals x. Now, if I ask you to do this, f of x equals 2x. Well, it still have this direct variation relationship. The difference is the slope. The slope is 1 and now it's 2. So every time when x increases by 1, it goes up by 2. So that's a new one. So f of x equals 2x. So when you set this coefficient before this x is 2, that means you are, from here you stretch. So you stretch the parent function's graph by a factor of 2. Stretch by vertically by a factor of 2. Okay. What about a 3x? Of course, you're going to stretch vertical. My V is not beautiful. Stretch vertically by a factor of 2. What about f of x equals 1/2? So that will go to here, right? So it's going to be like this, a flatter. So you compress or shrink the graph vertically by a factor of 1/2, shrink to 1/2 of it. Okay, so that's a general idea. So you can see this number before x, it tells you whether you should stretch or you should shrink vertically by that factor. If it's 2, then stretch. If it's less than 1, it's 1/2, then of course you're going to press or you're going to shrink. Okay. The other thing is f of x, parent function, and we know is this, right? It's x and y, here is 0. What about f of x equals negative x? That's going to be, for every x, you get this function value. Now it's when x is here, so you get a negative 45-degree line. We call this reflect about, or you can say flip or reflect about x-axis. Okay. All right, now we learned this function transformation. That is important. We learned shift up and down. We learned stretch or press, and we learned flip over, right? So we learned all those things. Now, what about next one? What about the the transformation from the parent function? So now you see why this is parent function, right? All the other linear functions are just like the kids of that. So how do you get f of x equals negative 2x plus 3? Now I'll tell you what to do. If you have this graph, 45-degree, first thing is to do this. You're going to vertically stretch by a factor of 2. So starting from 45-degree, you're going to do as much. You're going to do this, right? Alright, so I just did it right that. Alright, so this is the 2. And then the next thing you're going to work is this negative. That means a flip over. Okay? Or you say reflect about the x-axis. So you're going to get reflect. So you're going to get this. Okay? And then the third step, that's shift up by 3. So starting from 0, shift up by 3. So you're going to have, okay, so here's the 3. And this is slope is -2. You see the idea? This is a step 1, this is a step 2, and this is a step 3. That's how do you work on the transformation of the function, the graph of the function, starting from the parent function. This. Okay? So I think that's all. That's already a lot. That's all for the graphing linear equation and the graph of the linear functions. And I hope that you can understand everything, because there's so many important concepts in this class, and I hope that you can know this from the beginning to the end, know everything about that, and then do very well in all the homeworks and exercises at the end of the book. All right. If you have any question, or if you're looking for more exercises, or if you notice that there's still something I didn't explain very well, you still don't understand the concepts. When you work on the homework, you get struggled, you can shoot me by an email. Just let me know, and I'll be happy to help you. All right. Now, good luck, and that's a lot. All right. Thank you. You should be very proud of yourself. All right. Bye-bye.